Hello everyone, I would like to present our hackathon project, Guac-AI-Mole. I'm sure many of you are familiar with the Log4j remote code execution vulnerability, which made the headlines a couple years ago. In an organization, when a supply chain vulnerability or attack happens, usually each team scrambles to find if their workloads are affected, which can be quite a tedious process. Today, many projects generate or planning to generate SBOMs for secure supply chain transparency. However, there's no clear alignment on where these artifacts should be stored and consumed, since these can be in storage accounts, container registries, or other places. Additionally, while SBOMs are produced, there is no central mechanism to track what dependencies are used where to make actionable decisions. Graph for Understanding Artifact Composition, Guac, is an open source project that gives users organized and actionable insights into their software supply chain security positions. Guac ingests software security metadata, like SBOMs, and maps out relationship between software so that users can fully understand and take action on their software security position. With this hack, we had four main objectives. First, Guac provides a GraphQL interface for querying the data. However, this requires being familiar with GraphQL to create and maintain queries. So first objective of this hack is to create a natural language interface for GraphQL using AI, so we don't need to create and maintain queries. Furthermore, while Guac supports SBOM registry fallbacks, it does not ingest supply chain artifacts from OCI referrer types artifacts. We would like to standardize on these for containers, so we can easily find SBOMs for applicable container images. This will be also a great contribution to Guac open source project. Guac does not know about images running on Kubernetes clusters. We would like to associate supply chain artifacts with containers running inside Kubernetes to be able to find running containers. Internally, we would also like to find owners of these clusters so we can directly communicate to service teams. This would speed up the remediation process significantly as we eliminate the bottleneck for each team to identify its own vulnerable dependencies. First, we would like to get our Guac instance up and running. We are going to use Docker Compose Up to create our Guac instance. Now that our Guac instance is starting, we are going to look at some of the images we are going to consume. This is from a specific branch that supports OCI artifacts, and we have prepared some sample images that have OCI referrers artifacts attached to it. So these are some of our images, and then let's look at one of them, for example. And here we can see that we have a SBOM file attached to this image. In the meantime, looks like our Guac server is up and running. So let's go ahead and consume these images from our registry. So now we're going to collect all the SBOM artifacts from our registry. So this process will take some time, and then go and looks at each of the OCI referrers artifacts in our registry, and we'll ingest them into Guac. Yeah, looks like we are done, completed ingesting 11 documents. So now let's look at our LLM-powered app using Streamlit frontend. So first, let's start with we can start with some sample questions. But if anybody wants to get this up and running with their own environment, they can add their own API keys in models in GraphQL endpoint to get started right away. This will only use some sample questions and answers that are generated by Guac-AI-Mole. So let's look at the dependencies of an Alpine images. So here we use SBOMs that are ingested into Guac that we saw earlier to find some of the dependencies of an Alpine image. And let's look at a different angle. So now we want to look at what images depend on the client Go package. So client Go in this case is a Go package, and we can find out which images are utilizing the client Go package. For example, we have Core DNS, Kube API server, and more utilizing this package that we have seen some of the sample images ingested. So for the next example, let's look at a package and then which package contains this vulnerability. And then this is the log4j vulnerability that we spoke earlier. And then we were able to query the database using natural language and find that this is related to log4j core. And let's see if we have any actual images running with this vulnerability. And then similarly, we were able to query our Kubernetes cluster, and we found that this image is indeed running in ghcr.io guac-AI-Mole image.